welcome to Kobe's Math Nook. This is the continuation of our previous lesson on orthogonal trajectories. And our fifth example on this concept says, find the orthogonal trajectory to the curve y equals c sec x. Solution. We have y equals c sec x. First, we need to find the gradient of this particular curve by differentiating with respect to x. And this gives us dy dx equals c. When we differentiate sec x with respect to x, we are going to get sec x tan x. Also, we learned that you need to find this constant by making the constant the subject from the given curve. So you can say from y equals c sec x, our c becomes y on sec x. So substituting this c into the slope of the curve, we will get dy dx equals first the constant y on sec x dot, then what we have here, sec x tan x. And you know obviously that sec x cancels sec x, which will give us dy dx down to be y tan x. So this is the slope of the given curve. For orthogonal trajectories, the slope of the orthogonal trajectory becomes dy dx equals, we learned that the slope of the orthogonal trajectories is the negative respect to that of the given curve. So we get negative 1 on y tan x. So now that we have the slope of the orthogonal trajectory, now we can solve for the equation of the orthogonal trajectory. And this function is a separable differential equation. Separating, we are going to get this y will go, and we have y dy negative dx on tan x. But we shouldn't forget from trig that cot x is the same as 1 on tan x. So that means we can replace the cot x over here. So doing so, we are getting y dy equals negative cot x dx. We can integrate, and integrating the left hand side, we will get y squared on 2 negative ln sine x plus ln c. Note that when you integrate cot x, you are going to get ln sine x. Simplifying further, we will get y squared equals negative 2 ln sine x plus ln c. This is a constant, so I can choose not to multiply by the 2. Finally, that gives us, so we have the c and this negative, so that will be under that. Then we can, from logarithm, we can move the 2 here, and that will give us sine square x. And that is our orthogonal trajectory to the curve. So this means that the curve y equals c on sine squared x is the orthogonal trajectory to the given curve y equals c sec x. And with that, so as you can observe from the diagram, the blue curves represent the family of curves y equals c sec x. The red dashed curves represent the orthogonal trajectories y squared equals c on sine squared x. Then you can see that you have a purple point over there, which indicates the points of intersection between the two families of curves. So these points demonstrate where the given curves y equals c sec x are perpendicular to the orthogonal trajectories y squared equals c on sine squared x. Actually, you will not be asked to show any diagram, but I just brought this one up for you to see the reality of the concepts. Now let's look at the second example. Our next problem says we should find the orthogonal trajectories of a system of circles which pass through the origin and have the centers on the x-axis. Note that this problem talks about two things. One, circle which passes through the origin, and secondly, it has a center on the x-axis. Solution. First of all, we know the equation of finding a circle with centers A and B and radius r to be given as x minus a squared plus y minus b squared equals r squared. And note that the a and b is the center and then the r is the radius. But per this particular problem, it says that they have their centers on the x-axis. So that simply means that the center for the y coordinate will be 0, whilst the r is the same as the a. And with that, we can say that we are going to have x minus a all squared plus y squared, because the b is 0, because then the r is the same as the a, and that is also a squared. Now that we have the equation of a circle which passes through the origin and have their centers on the x-axis as this, now we can find the slope of that particular equation. Slope of this, let's differentiate. We are going to get 2 by x minus a, then we subtract 1 from there, times differential of what we have there, and that still give us the same thing, plus 2y dy dx, and that is equal to 0. Why 0? Remember that we know that this particular a is just a constant, is a value. So whether it is squared or whatever, so it will give us a value. Everything here is a value, and when you differentiate a value, you get 0. In that case, we are getting 2y dy dx equals, then let's expand and move it to the other side. That will give us negative 2x plus 2a. Making dy dx the subject, we are getting dy dx equals negative 2x plus 2a on 2y. And you can see 2 is common, so we can factorize that one out, and that's our dy dx becomes negative x plus a on y. At this very stage, we need to find the constant a in this, and from that we can get it from making it a subject from here. So let's try to expand this and see what will happen. So from when we expand x minus a squared, this will be squared, and know this and this together, that will give minus 2ax, and then we square this one too, that's plus a squared plus y squared equals a squared. Of course, this will go out, leaving x squared minus 2ax plus y squared equals 0. Negative 2ax equals negative x squared minus y squared, and that simply will be equal to a equals negative x squared minus y squared all on negative 2x. Getting rid of the negative, our a now becomes x squared plus y squared on 2x. So substituting a back into the dy dx, and we know that our dy dx equals y. So let's substitute the a. Our slope becomes negative x plus x squared plus y squared on 2x all on y. Let's simplify this algebra over here, and our dy dx becomes, okay, let's take LCM for this to be 2x, and with that here we're going to get negative 2x squared, and the same thing will be there, divided by y. Simplifying, we are getting negative x squared plus y squared on 2x by 1 on y, of which finally we are going to get negative x squared plus y squared on 2xy, and this becomes the slope of the given curve or the given circle that we are trying to find its orthogonal trajectory. So now for orthogonal trajectory, the dy dx now becomes negative reciprocal of this, and that will be negative 2xy on, let me turn this, y squared minus x squared. At this stage, we have to solve for the equation of the orthogonal trajectory. And so what type of differential equation is this? If you watch it carefully, you realize that it's homogeneous differential equation, all because if lambda is here and lambda is here, lambda squared, so this one will give us lambda squared, this also give us lambda squared out, and that will produce homogeneous. Please, the ability to identify the type of differential equation is very, very important as far as ODE is concerned, so take note of that. Since it is homogeneous, we learned that we need to let y to be ux. Let's substitute y into this, and now the y dx becomes negative 2x ux on ux all squared minus x squared. So our dy dx becomes, now when you factor the x out, x by x will give us x squared negative 2u on, and this 2 we can factor x squared out, x squared, and we have u minus 1, u squared minus 1. So we cancel x squared, and dy dx becomes negative 2u on u squared minus 1. Let's label this as equation 1. And from y equals ux, let's try and differentiate this with respect to x. So this, we're going to get the y dx equals, differentiate the u with respect to x, we are going to get x du dx plus differentiate x with respect to x will give us the u, and let's label that too as equation 2. Equation 1 equals equation 2. Equation 1, we had negative 2u on u squared minus 1, and the equation 2 is x du dx plus u. Moving the u to this side, negative 2u on u squared minus 1 minus u equals x du dx. Simplifying this part, u squared minus 1 minus 2u, this by that, we are going to get negative u cubed plus u, which is equal to x du dx. And we can simplify this part, and that gives us negative u minus u cubed on u squared minus 1 equals x du dx. Now we can separate. Separating, we are going to get the dx on x, then we reciprocate this, that will give us u squared minus 1 on negative u minus u cubed du. Integrating both sides, integral of the x on x equals, let me factor the negative below, the negative at the denominator side, negative integral of u squared minus 1 on u plus u cubed du. So this is clear, it's easy for us to find. We know this is going to give us ln x, but we need to take this side. So taking the right hand side, and we know that that's integral of, let's factorize the u out, 1 plus u squared du. You know, the best approach here, we can use partial fraction decomposition to help us to solve this. So let's do that, and with that we can say that our a on this u plus, this is quadratic, so we can say bu plus c on the other parts, 1 plus u squared. So simplifying this, we are going to get the denominator u bracket 1 plus u squared, and simplifying, we are getting a by 1 plus u squared plus u by bu plus c. So now we can equate the numerator to what we have here. So since they are corresponding, it means u squared minus 1, then a1 plus u squared plus u bu plus c. So analyzing this critically, you can see that if we let u to be 0, we can easily find a. This goes 0, this goes 0, this goes to 0, everything here will be 0, and a will come out. So we can say that when u equals 0, then -1 equals a. That implies that a is equals to -1. So u squared minus 1 equals au squared plus a plus bu squared plus cu. So we can also consider those with a degree of 2. So we can say, comparing, we can say that 1 is equal to a plus b, but we add a to be -1. So this implies that 1 equals -1 plus b, and hence we get b to be 2. Let's compare those with only u, and that is only c over here. So we can say c is also equal to, we have c u. There's no u at the side, so that will be that. Substituting everything back into this, we had our a to minus 1 on u, and our b was 2, so we get 2u, and this becomes 0 on 1 plus u squared. And remember that we had negative integral already there, the u. Applying the integral to that, we are getting integral of 1 on u, the u, then negative integral of this negative 2u on 1 plus u squared, the u, and this gives us ln u, and this also gives us ln of the denominator 1 plus u squared plus c. Somebody may ask why. You can see here, if you let this one to be maybe say w, and you differentiate, to come and cancel out, and what we're going to have at the numerator part to be the same as the denominator, and hence that will lead us to this. So we'll see why. Taking only that side, let me show you why I wrote that. So you can say let w equals 1 plus u squared, the w equals 2u du, making the u the subject, the u becomes the w on 2u. Substituting everything back into this, this was w, and then the u now is the w on 2u. You can see this cancel this, 1 on w gw, and that is negative ln w, and that's negative ln, and it's the same thing as what I wrote. So always note that time you're integrating a particular differential equation, and you realize that whatever you have the denominator, when you differentiate, it gives you what you have here. It will lead to ln. That's the smartest way to know that. Now, integral of the x on x equals u squared minus negative integral of u squared minus 1 on u plus u cube du now becomes ln x plus ln c equals ln u minus ln 1 plus u squared. So this we are getting ln cx equals ln u on 1 plus u squared, and you know we are going to get cs equals u on 1 plus u squared. But we learned that y is equal to ux, and hence implies that our u is going to be y on x. So substituting y on x in place of the u, that gives us cs equals y on x on 1 plus y on x squared, of which will give us y on x by, when you simplify what we have here, we are getting x squared on x squared plus y squared. And finally, that gives us cx equals x y, this cancel this, one of this, and all on x squared plus y squared. And that is our orthogonal trajectory. If you want to know how it will look like when this particular curve intersects the circle, the system of circle, this is the diagram. So you can see the orthogonal trajectories, or the orthogonal path, intersecting a circle at an angle of 90 degrees over there, and that is very, very important, and that is how it will be. Thank you very much for watching. There are more examples out there. Please try and solve more problems on this for better understanding. Like, subscribe, and share to your colleagues. Thank you very much. Bye bye.